Mm. Hello friends, on this video I will explain ownership in Rust. I will explain it very simply because I found some people on the internet overcomplicating this stuff. I don't know why they are overcomplicating this stuff, I don't know why. But on this video we will make it very simple. Please know that I'm not a Rust expert, I'm just some dude on the internet teaching you Rust. Keep that in mind. Let's get right into it. So we have our Hello World program here. Let's run uh, cargo run Hello World. So it works. So we will do here, we will create a string variable and assign a value. For example, let name equals string from Muhammad, for example, and print ln hey name. And if we run this, hello Muhammad, so it works, everything's fine. But if we tried to assign this variable to another variable, in other languages you can just like copy the variable into another variable. Let's see, let's do let full name equals name. We assign a variable to another variable. This is like simple, it should work. Let's do, oh, it didn't work. Why it didn't work? It didn't work because in Rust we have what's called ownership for every not for every variable, but for the strings and variable that live in the heap, they have owners. And this string now, the owner is name. And if we assign it to another variable, the owner now is full name. Who is the new owner? Like, you sold your car. This is the new owner of the car. And now if we went with the new owner and just cargo run, it works just fine. But we can't go with the old owner. So the old owner give the value to the new owner, and the old owner is gone from the memory. How does this works? Is like the old owner gives not the value in itself, the content in itself. It gives it the pointer and the length, the capacity. This is like the out of the scope of this video. Well, I'm just explaining that it doesn't give it the content of the value. It just gives it the pointer. Where does it live? The content lives in the memory. We pass it to this one. I think I'm overcomplicating this, but it's very simple. Like, this guy give me the address where this lives in the memory, and you give it to this guy, and this guy is the owner. Very simple. But what if we wanna give the value to the full name, but at the same time we still wanna use name? How do we do that? So how do we do that? We have a thing called the borrowing. Borrowing is just giving the reference to another variable. You say, hey, here is, I borrow you this thing. I didn't give it to you. You're not the owner. I'm just borrowing you this thing. And how does this work? You just come here and you do this sign here. And hey, full name. Let's do also hey and name. And now if we run it, oh, let's do that. Cargo run. If we run it, we have the hey Muhammad and hey Muhammad, both of them. So now this guy is the real owner. This guy just borrow with it, and this guy just has the reference of the variable. It doesn't have the it's not the real owner. We can do it this way, or also we can do it the clone way. The clone like clones everything, and it's not a very efficient way to do things. So if we run cargo run now, yeah, it works on both. Now this is like very simple. Let's move into functions. How borrowing and ownership works variable with functions. For example, let's keep this here. Let's make a function and say move ownership, and give it a parameter of string and just print ln and hey from function and you just give it a string, you know, very simple. So if we run this now, we need to call the function. So if we come here and call the function, move ownership and give it the name, let's see, gotta go run, it works. Hello Muhammad, hello from the function is some function, doesn't matter actually. So now everything works. But if we change this with this, like if we now give the value to the function and then we use it later, let's see what will happen. Cargo run. Oh, problem. There is problem here with the borrowing. What happened? So the problem here is in Rust, if we pass a variable to a function, the function takes the ownership, is now the new owner. Even if you pass a parameter, yes, to a function, the function takes the things. So also there is two way to work around this. We can give it the reference, like the function will borrow the value and will not have the real value, the real variable, or it will not have the ownership right to the variable, it just will borrow it, or we can just clone it and give it the cloned one. Okay, so yeah, we can just come here if we wanna give it a reference. Here is, we put the reference, so it will borrow it. And now if we run it, cargo run, boom, it works. Hello from the function Muhammad and hey Muhammad. Why it works? Because now we're not giving it the actual variable, we're just giving it the reference. We're not giving it the ownership. Just take the reference and go away, you know, don't take the actual ownership of the value. So yeah, so for example, let's make a copy. Let's like call it full name equals name, copy like this, no, clone like this. And now we can just pass the full name here, full name, and cargo run. Let's remove this sign of the borrowed. Cargo run, everything works just fine. Now we give it the clone and we use our variable here, still there. The clone is not the most efficient way, not the most efficient approach. You usually wanna use like reference or like give the ownership, and yeah. So on this video, I expected you already know how why you would want to use the ownership. I just showed you example of how it works, and of course you know that ownership is for values that lives on the heap, not on the stack. So it's actually like overcomplication stuff. Let's keep it very simple. If you guys need a video about heaps and stacks and keep it very simple, just say it in the comment. Thank you for watching, and thank you for watching. That's it.